This is the Scratch program for the Scratch applet 2H1T or 2 heads 1 tail, which is based on a 3-coin flip. In this mathcast, we're going to look both at the 3-coin flip part, which can be easily adapted to less coins or more coins, as well as the algorithm for 2 heads 1 tail, which also can be easily adapted. First, let's look at what happens when flip equals 1. So we've set a single flip to happen. We click on the flip button, watch the coins. One flips after the other, and we have tails, head, head. So in this case, just notice that the total number of 2 heads 1 tail, because this is actually 2 heads and 1 tail, has increased by 1. One flip has taken place, so the total number of flips is 1, and the ratio of total 2 heads 1 tail to total flips is 1. So that's how the algorithm counts. Okay, but let's look at the coins flipping first. Let's click on coin 1 sprite. Here is the program or scripts attached to coin 1. It says when flag is clicked, which is the reset button, set it back to costume 1, which is the heads. So notice that we have tails, heads, heads. So if I click on the green flag, these should all go to 0 and these should go to heads. Clicking. This went to heads and these all went to 0. Okay. So this part here, it says set flipping to 1. That means flipping is now going on. That's a cautionary thing for children so that they can't keep pressing on the flip button and have it all mess up the counting and stuff. It says I'm flipping. You can't press on the flip button. We'll show you how that works. This part from here to here is the standard animation by H. Wilson that goes through these costumes. Look at these cool costumes you made with a coin and a shade and a smaller coin and a smaller shade, etc. And there it goes all the way up, and now it's coming down. And in the end, it has to choose between the heads costume and the tails costume. How does it do that? Right here, it says set H1 to pick a random 0 or 1. And it says if H1 is 0, set it to the heads costume. And if H1 is 1, then it's going to be the tails costume. What's the difference between coin 1 and coin 2? Coin 2, we don't have a flipping. That's only on the first one. So this right here that's set flipping to 1, we don't have. What we have in its place is wait 0.3 seconds. So it says wait before starting to flip this one. And then just do the same thing and then generate a heads or a tails for the second coin. What's the difference with the third one? The third one says wait another 0.3 seconds. So there's 0.3 seconds between the first two, and then another 0.3 seconds, or a total of 0.6 seconds before the third one starts to flip. And it says when you get here, generate another heads or tails for H3. And it says, okay, we're done flipping, so set flipping to 0. And broadcast done. What do you need to change if you want to increase or decrease the number of coins being flipped? The thing you do is you take this part right here off. You increase or decrease your coins, and on the last coin you have, you put this back on. And of course, you want to increase 0.6 if you've got more coins, and you have to define new variables, H4, H5, if you've got more coins. But this is the part that you attach right here. You saw me take it off to the last coin. Now, that's all you need to do to change the number of coins. So let's go to the flip. So what happens when we click on the flip button? When flip is clicked, it says, if flipping is not taking place, go ahead and do something. If flipping is taking place, then don't do anything. That's to keep children from non-stop clicking on the flip button and having it do weird things with the numbers. So it checks to make sure that no flipping is taking place, and it starts the flipping algorithm. And it says, if flip is greater than 1, then don't do the animation. Simply tell it that it's flipping and start generating 3 random numbers and calculating the probability. And if flipping is equal to 1, which is, if it's not this, then this. Then broadcast flip all, and it will do the animation. Flip all was, remember, the broadcast that flipped the coins. When it comes back from flipping them, it has done, and it does recalculate. So when flip is clicked, what happens is we get H1, H2, and H3, and we're told to broadcast calculate. This part down here doesn't change unless you add or subtract coins. Then you would put another coin in here. You would put more or less variables in here. So what is the calculate part? This is the part that calculates the probability. If you're using a 3-coin toss, you need to do nothing but change the variables here and the algorithm here. That's what we're doing on a separate place for a conditional probability that has a 3-coin toss. So what is the part we change for this particular probability problem? That is, we want to know in 2H1T what number of the total flips has exactly 2 heads and 1 tail, and what is the ratio between the number of flips that has 2H1T and the total number of flips. So we need to define 2 new variables, one called total blank 2H1T, which will calculate of the total flips, how many have 2 heads and 1 tail. And then we have another variable that calculates the ratio between total 2H1T and total flips. The name of this variable is 2H1T/total. These are the names of the variables. You can put almost any name you want to in Scratch. Okay, what I've done is make those variables and tell it when reset is clicked, set them to 0. So these 2 lines I've added. I've created these 2 variables and added these 2 lines. Now I need to have the calculate part. So I go over and I look at my calculate script. When I receive calculate, change the total flips by 1. That never changes because when I receive calculate, it has generated a 3-coin flip. So now I want to know, do I change total 2H1T by 1 or not? I would only change total 2H1T if I had a flip that had 2 heads and 1 tail. So how do I check to see if it has 2 heads and 1 tail? Well, the sum H1 plus H2 plus H3 tells me the number of tails. That's the way it's set up. These variables are 0 if it's heads, and they're 1 if it's tails. So if this sum is 0, then all of the flips were heads. And if the sum is 1, then exactly one of the flip was a tail, which is what we want. If it's 2, 2 of the flips were tails and 1 was a head. And if it's 3, all of the flips were tails. So we say, if it's equal to 1, that's what we want. So then change my variable total blank 2H1T by 1. And if it's not 1, don't do anything. And finally, reset the ratio, or set the ratio to the total here, divided by the total number of flips. This is the entire algorithm for calculating the percentage of total 2H1Ts to total flips.